All right, here are the next 10 questions in the midterm review, number 11 through 20. Let's go. All right, question number 11. What is the domain for the following piecewise function? Domain is left and right, all the x values that are allowed. So if I look at my domain, this arrow is pointing left forever, and it stops until it hits, I don't know, whatever that number is. I would say maybe 5. But then up here, oh, -5 right there. And then up here, it's including -5. So even though it's open circle there, it's included there. Everything between -5 and 3 is graphed, not including 3 in this open circle, but including -3 down here, and then it's pointing to the right. So there is no x value that you could not plug in somewhere. So your domain would be all real numbers. All real numbers is -infinity to +infinity. On the graph, which portion of the piecewise function is represented in red? So let's look at the red portion. It looks like it's a linear equation, and it's got a slope of 1/2. So it looks like it has a slope of 1/2. So if I extend that, it should cross the x or the y-axis right here, maybe at 2.5. So let's take a look. So everything to the right of 1 is included. So x would be greater than 1 in that case. So it looks like it crosses at 2.5 and has a slope of 1/2. So I'm going to say this one here. Before I do that, we'll go ahead and graph it. And you can graph in piecewise functions just to verify. You can say, if I want to graph 0.5x plus 2.5, and I want to only include the portion that's greater than 1, I can do squiggly bracket, x is greater than 1. And I can see and verify that that is indeed going to be the same thing. Now, if I did the other one, 0.5x plus 2, that's a little bit too low. And you see it's going to cross there at 2, not 2.5. But I'm fairly certain that's going to cross at 2.5 because that's right between 2 and 3. So let's click that one. And I'm catching up. All right. F of x is greater than or equal to 1 minus 1/3 x minus 3. Select the correct graph. Of course, we're just going to graph that. F of x is greater than, you get the greater than, shift period, and then hit equal. And then you do 1 minus 1 divided by 3, right arrow, shift, absolute value is right above enter, shift the vertical bar, and then you do x minus 3, close it up. Oh, we got to do y, and these ones I forgot. So change that to y. All right, so it's going to be solid line here, shaded above there. That vertex is in the first quadrant. So it looks like it's going to be one of these two. I think it's this one. It's kind of hard to see. Okay, find the solution. Y equals x squared minus 4x plus 6. Y equals x plus 2. Graph them, see where they cross. This one's probably the quickest one on this whole thing. 1, 3, and 4, 6. 1, 3, and 4, 6. All right, 15, match the graph with the correct equation. Well, this is 3 different unique parts. So first thing I want to do is eliminate that one. Now, if I look at the inequalities, these two are the same, and this one's different. So let's look at what's going on here. If I zoom in a little bit, notice that's an open circle, and that's a closed circle. So open circle is less than, so anything less than 1 for that first one there. And notice that this one says less than or equal to 1, whereas this one says less than 1, and that one says less than 1. So it's one of these two. Now, looking for the middle one, it's between 1 and 4, but it's including 1, but not including 4. So it's going to be greater than or equal to 1, but less than or equal to less than 4. So greater than or equal to 1, less than 4. Looks like it's going to be this one here, because that's going to be 1 and 1. And so the last one is greater than or equal to 4. So if I just base it off of the inequalities, it should be this one. Now you can graph this. You can say y equals negative 2x plus 1, squiggly bracket, x is less than 1. You can say y equals x, squiggly bracket, 1 less than or equal to x, less than or equal to 4. And you could say y equals x plus 1, squiggly bracket, x is greater than or equal to 4. When you do that, take a look at that graph, we can verify that that is pretty much the same thing. So, should be that one. (16) What's the equation of the graph below? Well, it's an absolute value. It looks like it's been shifted right to, and it's reflected. So right 2, remember, right 2 is the opposite signs are right and left, so it should be -2, but since it's reflected, it'll have a negative out front. So you can verify that. Right there, negative x minus 2. No, I'm catching up. All right, what is the equation of the graph below? Another graph there. This one's going left 4 and up 2, so it'll be x plus 4 in the absolute value, and then plus 2 on the outside. It is still being reflected, so it's going to have the plus 4 and the plus 2, but a negative. We'll verify. And there you go right there. All right, for this question, it says, what is g of negative 4 minus 5 times g of 0? Well, I'll just plug some numbers in. So g of negative 4 is less than or equal to negative 1, so we're going to plug in negative 4 there. So negative 1 over 2, parentheses negative 4, plus 1 over 2. That gives you 2.5. G of 0, well, 0 is greater than negative 1. So if I plug in 0 for 0 squared, that's going to be 0. And then if I multiply that by 5, no surprise there, that's still going to give you 0. So that's nothing. So this number right there is 2.5. 2.5 is the same as 5 divided by 2. On 19, what's the equation of the absolute value function? This one's a skinnier one, so it's going to be vertically stretched. It goes right 3. So I'm going to say x minus 3, but it's going to have the 4 because that's going to make it narrower. So if you do 4 parentheses, or absolute value of x minus 3 versus 1/4, the absolute value of x minus 3. I'll show you the difference. The 4 makes it skinny. The 1/4 makes it wide. Skinny is vertically stretched. Wide is vertically compressed. So we want the one with the 4. All right, last question. Are these inverse functions? No, yes, no way to tell. Inverse functions are reflections over the diagonal line y equals x. Here's an example. An inverse function, let's say x squared, we'll just say for x is greater than 1, so we can just focus on that portion of, or 0. And the square root of x squared, SQRT, those are inverse functions because they're reflections over the line y equals x. See, that's not a reflection over the line y equals x. That would have to go there. That's not cutting that in half. So they're not going to be inverse functions. That's just literally just the function shifted left. All right, we're halfway done. Tune into the next video to get number 21 through 40.